do our homework video. Hopefully this is helpful to you and you can get this from a video even though I'm not doing it in class. So let's start out. Lesson 58, number 5. I have to read this one from the book. It says, the lone wheel rolled down the mountainside until its linear velocity was 100 miles per hour. So the linear velocity, that's this big V, was 100 miles per hour. Miles per hour. Then it says, what is its angular velocity in radians per second? So we want to get the angular velocity, which is that one, in radians per second. Radians don't have a unit, so at the end we're going to be crossing out all the units and we'll be left with radians. Sometimes they'll say they want the revolutions per second, and you have to use this conversion factor. 1 revolution is equal to 2 pi. Okay, so we also need the formula. Linear velocity equals angular velocity times the radius. And finally, we're going to need the radius. So the radius in this problem is, the diameter is 80, so the radius is going to be 40 centimeters. So this is just a problem of unit conversions, is about all it is. We want the linear velocity right there. So we have to solve for that letter. So we get angular velocity equals linear velocity divided by the radius. The angular velocity is equal to, now we have the linear velocity, so it's 100 miles per hour over the radius, which is 40 centimeters. And we can rewrite this as 100 miles per 40 centimeters hours. If I put this over 1 and flip it, that's what we get. Now our goal is, when we're going from angular velocity to linear velocity, is to cross out every unit. And the only other thing we have to do is we want this to be in radians. This is what we're looking for, the red box. We want it to be radians per second, so we are going to have to change our hours into seconds. Just remember, to get radians, it's not going to show up. To get radians, you want everything to cross out, and radians is the assumed value. So we just start with our unit conversions. We can do the hours into seconds first, just because that's really easy. So we have 1 hour is 60 minutes, and then we get 1 minute is 60 seconds. So our minutes cross out, our hours cross out, and we have it in seconds. So we have the first thing done. Now the goal is to get rid of all the other units. So let's just start. Let's get rid of miles. So we know that there is 5,280 feet in a mile. And we know that there are, so the miles cross out. Now we have to get rid of feet. So we're going to get feet into inches into centimeters, and then everything will cross out. So we're going to get that there's 12 inches in 1 foot. So get rid of the feet. And we know that there are, we're going to get inches down here, there's 2.54 inches in a centimeter. So look, this crosses out with this. These centimeters cross out, and we don't have any more units. So if there's no more units, it's in radians. So then you just multiply all that with your calculator or the book. They just give you an answer like this. You just put all these guys together on the top over what's on the bottom, which is 40 times 60 times 60. Right across the second. Oh, we need the second. And that would give us radians per second. Now if they ask you to put that in revolutions per second, if they did, you would take it times 1 revolution over 2 pi. And so you would have to multiply all this by 2 pi. And that would be, you would have revolutions per second instead of radians per second. Okay, problem number 1 is done. Let's move on to another one. Let's do number 19. 5819. I was glad that you guys had similar problems. I think, Michelle, you changed yours because I started working on a problem and then you changed it somehow or other. So this is lesson 58, number 19. This problem is 2 cosine of theta equals the square root of 3. And I think it gives you a range. 19 is, 0 degrees is less than or equal to theta is less than 360 degrees. So get the cosine by itself. Cosine of theta equals pi square root of 3 over 2. And you should know by now what this is, that this is 30 degrees, but if you don't, you can always make your little chart. Remember, cosine is x over the hypotenuse. So if we draw our triangle, our hypotenuse would be 2, our x is the square root of 3. This would of course be 1. So this angle right in here would be 30 degrees. So theta equals 30 degrees. Now it's between 0 and 360. We need a positive value, so it will also be this triangle down here. Because this is the square root of 3, this would be 2, this would be negative 1, but that doesn't matter. We want cosine, which is adjacent over hypotenuse. So if we figure out that angle, if we go the whole way around all but 30, we're going to get 360 as your second angle. That's all there is to that one. That one's not too bad. Okay, 23 is our next one. 5823. Alright, this one is cosine of the arc sine of negative 1 over 4. Okay, arc sine is only between negative 90 and positive 90. So we only need values in between there. Because it's an inverse function, you have to restrict the range. So you can do a little graph if that helps you here. Remember, sine is y over hypotenuse. So your y value is negative 1 and your hypotenuse is 4. So our triangle would look something like this. This would be negative 1 and your hypotenuse is 4. Now you use that, we don't know what this angle is, so we don't need to know what that angle is because it's not one of our 30, 60, 90s. But what we ultimately want to do is take the cosine of these given sides. Now the cosine is adjacent over hypotenuse, and we don't know adjacent. But we do know we have a right triangle. So we would do negative 1 squared plus, this would be our x value, so we'll call it x squared equals 4 squared. And we would get x squared equals 16 minus 1 would be 15. So our x value is the square root of 15. This is the square root of 15. And then if we want to find the cosine of it, it would be adjacent, which is the square root of 15, over our hypotenuse, which is 4. And that's the final answer to that one. Okay. Next one is 5825. Let's see, we might not have enough room for this one. I guess we do. Okay, listen, 58, number 25. These ones just give me a headache. They're not that hard, but they are headache-ish. Tangent squared of 3 pi over 4 plus 2 secant squared over 5 pi over 4 plus cosine of 5 pi over 2. Now it would be really good if you can think in radians where it would be and what angle would be associated with it. But if you're weak-minded like me, you have to change it into degrees. So I'm going to change all of these into degrees. So 3 pi over 4 is 135 degrees. 5 pi divided by 4 is 225 degrees. And 5 pi divided by 2 is 90 degrees. You can make little charts if you need to, little graphs. So 135 degrees, we should know that's 45, right? Because it has a 5 at the end. So we would have, if it's going to be 135 degrees, we know that if it's tangent, this has to be 1, this is 1, this is the square root of 2. 45 is going to be 1 square root of 2. So the tangent, and this has to be -1. So the tangent is opposite over adjacent, so it's going to be -1 squared. The secant one gives everyone a little bit of trouble. What I do, and there's different ways, I notice other people do this differently, is I remember that secant goes with cosine, and cosine is always x over the hypotenuse, so secant is going to be hypotenuse over x. So let's just plot that up. So we get 225 is also 45 degrees, so we get 180, and then we're going to be left with 45. And we know it's going to be 1, -1, square root of 2. And I know cosine is adjacent over hypotenuse, so secant is going to be hypotenuse over adjacent. So that's going to be 2 times hypotenuse over adjacent, which would be -1 squared. Then finally, cosine of 90. You can do it 2 different ways. You can look at cosine 90. Here would be the point. The point would be 0, 1. Cosine is always x over hypotenuse. The x value is 0. The hypotenuse is 1. So it's going to be 0. Or the other way, now that we can graph these things, because we know this is going to be 1. This would be 90, 180. And you know the cosine curve goes like this. So we know the cosine of 90 is 0. But either way, you're going to get 0. And we're going to get -1 squared is 1, plus negative square root of 2 squared would be 2. 2 times 2 is 4. And so you're going to get 5 for your answer. Alright, let's move on to the next lesson, which would be lesson 59. Nobody had any questions for 60. So let's go on to 59. The sooner you can get these on the help board, the better, but I probably will end up doing these Wednesday night anyway, just so that they're all there. This is lesson 59:15. Okay, this is graph by completing the square. So you get y equals, I might have skipped a step, let me just check. Lesson 59:15. Hopefully I just didn't do this whole thing without my microphone. Okay, if so, I'm so sorry. Hopefully you can understood what I was doing. Complete the graph of the parabola. So we get y minus 3x squared plus 6x minus 5 equals 0. Okay, parabola is in the form y equals, if you're going to graph it, so it's going to be y equals, I'm going to bring everything on the other side, 3x squared minus 6x plus 5, and now we're going to complete the square. We wanted to get it in the form y equals ax minus h squared plus k. So, we can look at this, and does this say graph? This one says complete the square to graph. So we are going to graph it. This number right here, when it's in standard form, this is standard form, y equals ax squared plus bx plus c. This c value is always your y-intercept. So we know, even before we start, our y-intercept is going to be negative 5. Now we complete the square to get it into this form right here. So you get y equals, you cannot have a coefficient in front of the x squared term to complete the square. So we factor that out right away. X squared minus 2x plus blank. We kick that 5 right on out of there because it's not a perfect number. And we have to subtract whatever we add here, we have to subtract off there. So we divide our middle term in half. This is how you complete the square. And I didn't divide it in half. And then square it so we get 1. Now I would subtract off a 1, but that's not really a 1, it's a 3 times 1, so I'm going to subtract off a 3. And then, since we formed a perfect square trinomial, it's going to be x minus 1 quantity squared. That was the whole point of making this a perfect square. Minus, let's see, I made this should have stayed a plus. When I throw it out there, you don't change the sign, you just keep it positive. So it's going to be plus 2. Now we can quickly graph this thing. Our vertex is 1. It's our HK, so it's 1, 2. So I'm going to do that first. 1, 2. Our y-intercept, I told you, was negative 5. That should have been positive 5 because I copied this wrong. So it's positive 5. 1, 2, 3, 4, 5. And since it's symmetric, you would go, since it's over 1 here, up 5, you would go over to the right 1 and up 5. And you connect it and you get your little parabola. Okay, next problem. I've got a very crowded board. This is lesson 59, number 21. This problem says, sketch the graph for the parabola and then shade the regions that satisfy. So you get y equals x squared plus 2x plus 4, and then the other one that you graph a straight line, obviously that's a parabola, 2x minus 2. I'm just going to complete the square real quick to graph this. So you get y equals x squared plus 2x plus some perfect square number. Pop the 4 over here, and we're going to subtract off whatever we add. 2 divided by 2, again, this is really similar, is 1. 1 squared. So 2 divided by 2 squared would be 1, and then I'm going to subtract off a 1. And so my parabola is x plus 1 quantity squared plus 3. So let's graph that thing real quick. Yx, our vertex, is negative 1, 3. Negative 1, 1, 2, 3. Our y-intercept is 4. We know it opens upward because it's a positive coefficient from the x squared term. We have a point over here as well. So there's our parabola. Okay, this is a simple straight line. And if you look to see what we're going to have to shade, it's y is less than or equal to x squared plus 2x plus 4, and y is greater than 2x minus 2. So it's less than or equal to this, so I'm going to shade in everything less than the parabola. If you can't see that naturally, what you do is you pick a point like 0, 0, and see if it makes this true. If I put a 0 and a 0 in here, I get 4 on this side. 4 is not less than 0. 0 is less than 4, so you would color in that area. Now let's do the graph, let's do the straight line. So we get our y-intercept is -2, and our slope is rise 2, run 1. Remember all this? Hopefully this isn't hard. And this is not filled in. It's not and equal to, so it's just going to be a dotted line. And you want all the values that are greater than the line, so you're going to color everything above the line. And where the two intersect, which is above the line below the parabola, that's what you color in. So this is what it should look like. All this colored in. That's it. It's ugly, but that's how it is. Okay, next one, lesson 60. Oh, we're on the last one. Lesson 61:15. So, lesson 61, I'm so sorry if I didn't talk on that last one, because I had my headphones plugged in the microphone slot. Okay, 15, 61:15, let me look and see what that is. 61:15. Okay, these are fun. Last problem. Cosine squared theta minus 1/2 cosine theta equals 0. And does it give us a range? Yes, that's the old 0 degrees is less than or equal to theta is less than 360 degrees. So we can factor out a cosine of theta. And we're still left with the cosine of theta here, because we have 2. And here that comes out, so then we have 1/2. Now we set each of the factors equal to 0. Cosine of theta equals 0. And cosine of theta equals 1/2. We're not dealing with any 2 thetas or 3 thetas, so our angles have to be between these two angles. So we just, what angles give us 0 for cosine? Well, just think of your cosine graph. So we'd start here, that would be 1. The graph starts there, we have 90, 180, this is just a good review for us too, 270, 360. So the cosine curve does this, goes down there, comes up there, oops. And let me try that again. It's going to hit here, it's going to be -1, it's going to hit here, and it's going to be +1. So I should draw these and then put the numbers in the graph. So we can see where it's 0, it's going to be 0 at 90 and at 270. So those are going to be these two, 90 and 270. And then cosine of 1/2, we should know that, shouldn't we? So y and x, if it's 1/2, it's going to be our 60 degree, because we're going to have our 1, 2, square root of 3. So this would have to be our 60 degrees. And then we also have it down here at 3, this would be 60 degrees with a positive 1/2. This is adjacent over hypotenuse. So our other ones would be 60 degrees and 330 degrees. And I think that's the right answer for this. Let me just check real fast. Lesson 61. Number 15. 270, that should have been 300. I didn't subtract right. So let me just erase that. So this should be instead 360. Alright, hopefully that answered all your questions.